Hello friends, here's a little bit of a challenging problem. Here's the setup. There's an object that's dropped and it falls in the last half of the distance. It falls in a time of 1 second. So the last half, we're talking about half the time, half the distance. So the last half of the distance, it falls in a time of 1 second. So how long was the total fall? And also how high was the fall? There's also a follow-up question. Explain the answer to the quadratic formula doesn't make any sense. So there is a way of solving this problem that uses the quadratic formula. You set up a quadratic equation, you put it into the quadratic formula, and it gives you two solutions. One of them doesn't make any sense based on the situation here. The other solution is the right one. But I'm going to show you a way that you don't have to do that. Now here's a key thing. When you're setting up something like this, kind of a really challenging problem, setting up the diagram and the labels are super important. So here's what I did. I have this distance, the total distance, I called h. All right. And then, so this is the last half. I'm just pointing out here that this is 0.5 h. But I called the lower half y1, right? Or you call it y prime, y1, something like that. And then, actually I called it y prime. So I'm going to move this thing up here. And and I called the capital H y. So I've got y is the full height, y prime is the half height. And then for time, t prime is the time it takes to fall the first distance. And because it's the same distance as the bottom half, but it's going slower, right? It's still speeding up. I'm expecting that time to be more than 1 second. So the total time I'm looking to be somewhere in the 2 to 3 second type range. And but capital T, I'm going to label capital T as the total time it takes to fall down. And so now I have this equation, T equals T prime plus 1. It's 1 second, that's 1 s. Right? So that's just expressing what's going on with the time. And now I can set up two of the position equations, right? X equals 1/2 at squared. Initial velocity is 0. And I'm going to set it up for falling the first half, right? Actually falling the, so falling the first half and then falling the full time. So in both cases, the initial velocity is 0. So v naught would be 0. Instead of x, I have y, and instead of a, I have g. G is the acceleration due to gravity. And I'm making down the positive direction here, so I can just leave everything positive. It simplifies the whole thing. Now watch what happens. Okay, I'm going to solve both of these for t. And when I do that, I'm going to skip some of the algebra. So t equals the square root of 2y over g. Okay, good. Now I'm going to go over here. T prime equals the square root of 2y prime over g. This is g, right? Let me make that neater, g. But y prime is related to y. One of the key things I'm looking for is to get everything into the same expression, right? Or expressed in the same variable. So I've got y prime, I've got y, I've got t prime, I've got t. So if I know how y prime is related to y, right? Y prime is half of y. So I'm going to put y in here. So t prime is the square root of 2 times 0.5 y over g. So what am I doing there? 0.5 y, that's what y prime is equal to. Y prime is half of y. Made that substitution. And now what I can do is I can take these two equations and I can put them one over the other. It's a little trick. So let's see what this looks like. T prime over t. What's going on here? But watch and see what's going to happen. Because I have y in both expressions, y is going to cancel out. I'm going to eliminate one of the variables, one of the things that I don't know, and I'm going to get it down to t prime and t, and then I'll be able to plug that back into this other equation. Anyway, so let's just do it and see how it goes. So this is the square root of, the 2 and the 0.5 cancel out. So this is just y over g over the square root of 2y over g. And when I simplify this, I just get the square root of 1/2, right? Or the square root of 0.5. Now, that means that t prime is equal to t times the square root of 1/2. Okay, well, that works because now I have this other equation over here where I have t and t prime related to each other. I can plug that in. So t equals t prime plus 1. I'm going to leave off the seconds for now. So that means that t is equal to t times the square root of 0.5 plus 1. Now I have one equation and one variable, and I can solve that. What it looks like when you solve it is t equals 1 over 1 minus square root of 0.5, and you end up with t, total t, is 3.4 seconds. That's what I thought it would be, right, in the 2 to 3 second range, and that makes sense. So 3.4 seconds total means it's taking 2.4 seconds to fall that first half, and the last half, because it's going faster now, as it falls more, the last half it completes in 1 second. So what's the total distance? That's the answer to part A. What's the total distance that it falls? Well, that's easy now, because all we have to do is take this equation and plug in the value for t that we got, right? So this is going to be very simple. Y equals 1/2 g and then 3.4 seconds squared, and that'll give you 57 meters. That's the answer to B. Right. And if you do it this way, then the other question is really confusing. Explain the solution to the quadratic equation that doesn't make sense because you didn't use the quadratic equation to solve this. So if you didn't use the quadratic equation, that's okay. Don't worry about it. This is an acceptable solution, and I think a little bit simpler because then you don't need the quadratic formula. So I hope this was helpful. Again, this was chapter 2, question 60, actually problem 60, the way I have them labeled. Questions are like conceptual questions, and then there are problems. And this is problem 60 from the textbook. So thanks for watching. Don't forget to like and subscribe.